In this lesson, we're going to discuss how to find horizontal asymptotes. This is the note sheet that you'll find in the book. These horizontal asymptotes are rational functions where we can let f of x equal p of x over q of x, where p and q are polynomial functions in standard form with no common factors other than 1. We really only need to look at the degree of each polynomial. For example, our 3 bold points here are our 3 options. If the degree of p, which is the degree on top, is bigger, there's no horizontal asymptote. If the degree of the top one is smaller, the horizontal asymptote is y equals 0. And if the degrees are the same, we take the line, it is the line y equals the leading coefficient of the top polynomial divided by the leading coefficient of the bottom. So to break this down, here's what I've done. I've written this into simpler notes that you might understand a little better. I would encourage you writing these notes down. F of x equals, we got the top polynomial over the bottom polynomial. That's what these rational functions are going to look like. If the top degree is bigger, there's no horizontal asymptote. If the top degree is smaller, our option is only it's y equals 0. And if the degrees are equal, the top equals the bottom, then it's y equals the leading coefficient divided by the leading coefficient on the bottom. Let's dive into a couple of examples here. So we've learned how to identify the zeros and the vertical asymptotes. We're just going to focus on horizontal asymptote to start here. So the horizontal asymptote, we need to look at the degrees. The top degree, which is the highest exponent, is 2. The bottom degree is 1. So if we look at our options, the top degree is bigger. Therefore, for this first problem, there is no horizontal asymptote. That's just for the horizontal asymptote. When you get to this assignment, you're expected to find the zeros and the vertical asymptotes as well. So to find the zeros, remember, that's when the top is equal to 0. So if we wanted to find the zeros, you would say x squared plus x minus 6 equals 0. Multiply, get negative 6, add to get positive 1, x plus 3, x minus 2. So we have x plus 3 equals 0 and x minus 2 equals 0. Subtract 3 on both sides here, we get x equals negative 3. Add 2 to both sides here, and we get x equals 2. So my zeros are negative 3 and 2. And my vertical asymptote is when the bottom is equal to 0. Well, that would be the line x equals 0. That is our vertical asymptote. So when you get to the assignment, you're expected to do all 3. What I'm going to focus on is just the horizontal asymptote for the rest of this lesson. So for this, we are going to find the horizontal asymptote. Again, we look at the degree. So the top degree equals 1. The bottom degree equals 2. If you go back to our note sheet, hopefully you have the notes in front of you. I'm just going to click back to it quick. Top degree is smaller, it's y equals 0. The top degree is smaller, so the horizontal asymptote here would be y equals 0. Let's take a look at another example. We'll go with finding the horizontal asymptote. The top degree is 2. The bottom degree is 2. They are equal, So it's going to be the y equals, the leading coefficient means the number in front of our exponent. For the top one, our number is 2. For the bottom, our number is 1. It's not usually written out there. Therefore, we have a line y equals 2. I'm going to do, so there's each example. If the degrees are equal, it's y equals the leading coefficient on the top divided by the leading coefficient on the bottom. The top degree is smaller, y equals 0 is our horizontal asymptote. If the top degree is bigger, there is no horizontal asymptote.